Hello and welcome everybody. Today is the day 11 of our Smart 25 Days Challenge, and today we are going to make a decentralized marketplace. So, in this marketplace, we would be allowing anybody to just buy and sell different products. So, let us start building it. First of all, let us create our file called as marketplace. Then the first line is our SPDX command, or you can just use this. Everything would be done. Okay. So let's start creating our contract. Let's name it contract marketplace. Okay. So in this smart contract, what we are going to do is we are going to create two structs. One struct would be for the purchase, that is, who is the buyer, who is the seller, and is the purchase has been successfully completed or not, and these kind of details. For that, we are going to create a struct called as purchase, and we are going to create a very important struct called as product. So in that product, as the name suggests, you would have guessed it, that in this struct, all the details about the product would be there. So let's start making the structs. The first struct is product. The details such as name, these are the properties. Okay, and 26 price. This is the product available and address of the seller. Okay, so looks fine. So our first struct is complete. So now let's make the second struct called as purchase. P6 product ID. I don't think that I need to explain what a decentralized marketplace is. I know everyone must be doing what our marketplace is. So this is going to be a decentralized marketplace. Okay. So as we are using the blockchain technology, we are creating a smart contract. So it's basically a decentralized marketplace. Completed. Okay. So these are the properties of the purchase struct, such as the product ID, the buyer, the seller, the amount, and is the purchase successfully got completed or not. And if there is any, we are also keeping a option for a thing called as dispute. Okay. So what this means is, so say a buyer buy something and he was expecting something and he got something else in return. So basically in that case we can create a dispute. Okay, we would allow the buyer, or maybe in some cases even the seller can also raise a dispute. So what a dispute is, keeping the real world scenario in our mind, what we are going to do is we would be thinking that in the case of a dispute, our team or someone from our team, maybe we would be having some team of say 5 to 10 people for running this marketplace. So in that case, in the real world scenario, someone from the team would check correctly whether the dispute of whether the amount of the dispute should be given to the seller or to the buyer, whether the buyer is right or whether the seller is right. So someone from our team would be this resolving the dispute. Okay, so for that we have kept a property called as dispute also. So this is pretty much clear in itself, I guess. Okay, so in this smart contract, we would be using some mappings, events, and functions as we are using in the previous days also. So the mappings which we would be using in this smart contract would be, one mapping would be for the products. Okay, so we would be keeping the track of all the products, assigning them some product ID. Okay, and another mapping would be for purchases. Okay, and another mapping would be for purchase IDs. So what are purchase IDs? Purchase IDs are just like transaction hash or something. So what will happen is these purchase IDs will uniquely identify each purchase. Okay, so they need to be unique, and they will fulfill the purpose of uniquely identifying each purchase, so that in case of a dispute, or maybe for in the future, if someone wants to track their purchase, they can track them using these purchase IDs. So let's start making our mappings. If you guys are thinking that I am going at a very fast pace or something like that, then please go through my previous videos there, because in those I have explained all these concepts which I am covering here, such as mapping, structs, and all, in detail. Okay, so you can watch those videos if you feel like I'm going a bit fast. Okay, mapping view into 46 purchase. Let's call this mapping as purchases. Okay, another mapping called as purchase IDs. And in this mapping, what is going to happen is, oh, this is address. We are going to map the addresses for each buyer. Say if a buyer buys 10 times, okay. So for each buyer address, we are keeping a array of units, okay, and these units are what? These are the purchase IDs. I would be demonstrating them, and it would be more clear when I would demonstrate it. What it means is, purchase IDs. Okay, looks good. So, and now we are going to do one more thing. We are going, what we are going to do is, we are going to create two more mappings called as buyer balances and seller balances. So, the concept of this smart contract is, say, if a user wants to buy something, so the user will send that specific amount for which the product is the cost of the product to this smart contract, and that amount will be stored in this smart contract for a particular time until when the purchase has been marked as complete. So what will happen is, a seller will will add something to this marketplace. A buyer will send the specific amount, the cost of that product, to this smart contract along with that product ID, that which product he wants to buy. Okay, and that amount will get stored in this smart contract. Okay, and this smart contract will hold that amount for up and what will happen after that is, just imagine case of a real world scenario. So after the seller gets to know that, okay, the buyer has placed an order and he has sent the required amount into the smart contract, now it's the duty of the seller to send the product to the buyer's house, and then the seller will send that product to the buyer's house. Why, you may ask that maybe the seller may not send the product to the buyer's house and just keep the amount, but it will not happen, and I'll show you why it's would not be possible for the seller to just keep the amount. And so the seller will send the product to this buyer's house, and after receiving the product, the buyer will mark whether the purchase has been successfully completed, whether he has received the right product or not, or in case of any dispute, he can raise a dispute. So that's all what's going to happen. Okay, so for that, what we are going to do is, these seller balances. So the thing which I just mentioned is, the seller would not be able to just keep the amount. It's because until and unless this purchase has been marked as complete, the seller cannot retrieve the amount. Okay, the seller cannot withdraw the amount from this smart contract. So the seller has no advantage in not sending the product to the buyer's house. So after the seller gets to know that okay, the person has sent the amount to this smart contract, that means that the person is definitely willing to purchase this, and that's why he has sent this amount to this smart contract. And you may say that after receiving the product, maybe the buyer never marks the purchase as complete, and maybe the seller may never get to withdraw the payment. But it will not happen, because there is also no such advantage for the buyer to just not mark the purchase as complete, because he has already sent his amount to this smart contract, so he's not having that amount anyway. So it's of no use if he is not marking that purchase as complete. And you can even think of some advanced use cases, or you can make any improvements in this smart contract once we complete this, and you feel like there are some more changes or more advancement which can be made, so you can definitely make them. So first let us complete this smart contract, and then we'll talk about all the details while demonstrating this, while I will be demonstrating this smart contract. Okay, the working of this smart contract. So public buyer balances BO, another mapping called as seller balances. So after this, what we are going to do is, just as now I told you that in the case of a dispute, someone from our team, think of a real world scenario. Okay, someone from our team would be helping will be resolving this issue. So what we are going to do is, we would be making a manager. Okay, and who would be the manager? We are declaring state variable as called as manager. And who would be the manager? The manager would be the person who deploys this smart contract. Okay. So basically, the person who deploys this becomes the manager. And then we need to keep track of the product ID. Product ID. Okay. Just to keep track of product IDs. Okay. So now let's make some events also. So the events would be helpful, as I have to covered in previous videos. Okay, so events would be helpful for letting the outside entities know that what has happened, and to know what's going on this smart contract. So let's make some events. Okay, the first event would be when the product would be added, and more events would be when the product would be sold, when there is the completion of the purchase, that the purchase has been completed, and in case of a dispute also there would be a event. Okay, and when the dispute gets resolved there would be an event, and more events can be like when the funds would be withdrawn. Okay, so the when the funds would be withdrawn, then also the event can happen that okay, the funds have been withdrawn. So let's make the eh, first of all, let's define them. Product ID. Okay, you into 56. String name, price, address, index, seller. So let's make another event called as product sold. So this index keyword I have covered. Okay, so this helps basically to when the logs are being checked. So it helps by just it acts as an index. Okay, just as in the class we have roll numbers, so we have marked that the seller would act the address of the seller would act as the index for this specific event. Okay, product edit. And so in detail I have covered in my previous videos. If you want to know, then please watch my previous videos. And let's make this next. Okay, product ID, next seller, who is the seller. So here we are defining making two marking the seller's address also as indexed and the buyer's also as indexed, because we want to allow to anyone to look by the seller's address also, and anyone to look by the buyer's address also. Okay, so for in case of purchase completed, mm, purchase ID, purchase disputed, and then funds withdrawn. Looks fine. Okay. So now let's start defining the functions. First of all, let's define a constructor. Okay. And so we are basically marking the manager as the message.sender as the manager. Okay. So constructor is a special function. I have told you enough times that in my previous videos that the constructor is a special function which gets executed only one time, and that time is while the deployment of this smart contract. Okay, so that's it for this constructor, and now let's start defining the functions. So our first function would be add a product. Memory name as let's mark it external. Okay, so 56 product equals to the counter plus plus. Product memory. Basically, we are here defining new this product struct. Okay, this product struct called as product properties of this name, this price. Okay, true. Now, what does this mean is in the product struct you can check what is happening is we are assigning the values to this product struct. Okay, these are the properties, and what we are doing is the name would be the name provided by the user to this function. Okay, the price would be the price provided by the user. And what does this to means that yes, the product is available, and then the seller will be the message dot sender. The person who calls this add product function would become the seller. Okay, basically the seller will only try to add the product. Okay, so that's how we have defined this. Okay, and then let's, okay, looks fine. Okay. The products mapping, we would then, this is the key product ID. Okay, in the products mapping you can see the UN 256. Okay, that is the product ID, and then the product, it's mapped, it's being associated with the product struct. So would be product. So now we have associated the product ID, that is the first, in the first scenario would be 1, and products, the product ID 1, U256 value 1, and the value, the key would be 1, and the value would be the product, and the product is what, this product. Okay, so that's how we would have now completed our add product function, and we just need to emit that the event has been complete. Okay, so the event, what the event is, the product added. Okay, okay, okay. So product type would be product ID, and the name would be this, and the price would be the price provided by the user, and the seller would be the message.sender. Okay, looks fine. So now let us create some other functions, such as the function to buy the product, product ID, external payable. Okay, because we want this function to receive some ether. Okay, so we want the smart contract to receive some ether through this function. Storage product. Yeah. Products. This mapping, and the key is product ID. So basically what is happening here is, in this we were creating this struct and assigning the values. Okay, we were creating the new product struct, and here we are accessing the product struct. Okay, and what we are doing is, we are accessing which product struct, we are accessing the product struct whose key is the product ID. Okay, so in the products mapping, as you can see, at new 256 is the data type of the key, and the value is the product, so product struct. And what happens here is, we are providing the key, and accessing, retrieving that value. Okay, so the value associated with this key, this is the key, and the value is the product struct. Okay, so the product struct associated with a specific product ID is being retrieved here. Okay, so by, this should be by product. And now we'll first of all check whether the product is available or not. Okay, so require product available, otherwise we'll show that product is not available. Require message dot value double equals to product dot price. Okay, so the message dot value, the value sent with this function. Okay, while calling this function, the value sent should be equal to the price, otherwise we'll show that it's incorrect. Okay, so these are the required conditions, and now let's move forward. Okay, so purchase memory. So what we are doing here is just as we did with the add product function. Okay, we are creating a new struct of memo this purchase type. Okay, purchase memory purchase equals to product ID message dot sender. So the product ID would be product ID. The buyer would be the message dot sender who called this function. The seller would be we would be accessing the seller through product dot seller. Okay, because as I have told you in my previous videos, we can access the properties of a struct. Okay, in this manner. So we would be what we would be doing is just for the seller, we would be like product dot seller, and we would be accessing the value of the seller. Okay, like who is the seller. And the amount would be the message dot value, and bool completed should be the pro is it should be false initially, and the bool disputed should also be false. Okay, looks good. So now comes the part of our purchase ID. Okay, not product ID, it's purchase ID. And what it is, the main purpose of it is to uniquely identify each purchase. Okay, so this should be different, and no two purchase ID should be same. ABI dot encode back. And the things would be we would be using the product ID message dot sender, sender's address, the seller's address. Looks fine. And then Jesus purchase ID equals to purchase. Just as we did with the products mapping. Okay, we are doing that same with the purchases mapping. Okay, I hope it's very clear that in the purchases mapping, as you can see, what is happening is we are having a key as with the data type to unit 256, and the value would be a purchase struct. So we are associating that purchase struct. We have defined that here, and we are associating that with the specific purchase ID. Okay, so now let's do one more thing. Let's purchase message dot sender dot push. So what's happening here is, as I have told you in the beginning only, that the purchase IDs. Okay, so the purchase IDs, any buyer can buy any number of products. Okay, so for every buyer in the purchase IDs mapping, what we have done is we have created a mapping with the address as the key, and the value would be a uint 256 arrays. Okay, so an array of uint 256. And the what is this? This basically means that we are storing the purchase IDs of a particular buyer into an array, and we would be it would be helpful for the buyer to access them. Okay, so the first time a buyer buys something, the u into 56 array. Okay, so in the array the index would be 0. And similarly, when the buyer will buy, say a buyer buys 10 times, so the index will keep on increasing, and all the purchase IDs of related to that buyer would be stored in this purchase IDs mapping. Okay, I'll show you in while demonstrating. I would it would be more clear when I will show it to you. Okay, so okay, so here what's happening is the purchase ID is message.sender. Okay, by using this, what we are doing is we are accessing the retrieving the value, retrieving which value. First of all, purchase IDs is the name of the mapping. Okay, and this is the key message.sender. Okay, and then in that, what we are doing is this part purchases IDs message.sender. Up till this part what it does is it retrieves an array of u in 256, and then in that array we are pushing our new purchase ID. Okay, I hope it's very clear, but still if you guys feel any doubt or any problem, then please ask me in the comment sections. Okay, I would be happy to help you out, or you can connect with me on Twitter and LinkedIn also. Okay, so now let's make one important. See, that is to make the seller balance as to increase it. Okay, to increase the message dot value into the seller address. Okay, so seller balance product dot seller. Okay, seller balances. Here we are accessing this mapping, the address, and then u into 56. Okay, so the address of the product dot seller, and the value would be message dot value. Okay, if everything goes well, what will happen is the seller balances will get increased. Okay, I'll show it to you while demonstrating to be more clear. And then we will mark it this product as not available. Product dot label becomes false. Then we would be emitting the event that the product has been sold. Product sold. And in that product ID would be product ID product dot seller, and the buyer would be message dot sender. Okay, the person who's sending this, calling this function message dot sender. Looks good. Okay, looks good. So this function purchase by product and then add these two functions are complete. So now let us make another function called as complete purchase. As I just told you, the flow in which this marketplace will work. So for that we are creating this complete purchase function too. Okay. And purchase storage purchase, and then retrieving the value purchases and purchase ID. Okay. The things which we would be requiring here is that the purchase should not have been already marked complete. Okay, purchase dot completed, and otherwise what will happen, we will say that the purchase has been already completed. Okay, so looks cool. And the required condition should be that the person marking this complete purchase, okay, only the buyer should be able to mark this as complete purchase, not buyer Message or sender. Okay. Purchase dot buyer should be okay. The message dot sender should be the purchase dot buyer, and otherwise we will say unauthorized. Acquire, purchase dot disputed. Okay, and it should also require that the purchase should not be in the disputed category. Purchase under dispute. Okay, looks fine. And after these checks, we will mark the purchase as complete. Purchase not no completed equals to true. Okay, and then we would be emitting the event that the purchase has been complete. The purchase ID. Okay, looks cool, looks fine. Then we'll make the function for resolving the dispute and for allowing dispute. Okay, so there can be any dispute function dispute purchases, and we would be defining it with the help of purchase ID. Okay, purchase ID external. Then okay, accessing that struct. So, which purchase equals to purchases purchase ID. Okay, looks fine. Cool. Some required conditions such as the purchase should not be have already been marked complete, or the person who is calling this dispute purchase function should only be the buyer or the seller. And another thing would be the or dispute should not have been already marked. Okay, so we should not allow anyone to mark dispute two times. So purchase is dot completed. I will say that purchase has been already completed. And that's all. After this, we'll check that the person calling the function should be the buyer or the seller. And or purchase not seller. Okay, otherwise we'll call it as unauthorized. Then another required condition would be to check the that the product should not already be, it should not be in the disputed category already. Purchases already disputed. Then after that, we'll mark the purchase as disputed equals to true. Then emit the um, purchase disputed purchase ID. Looks fine. Now let's make another function called as resolve dispute purchase ID. It require the purchase ID in the solution. So who would provide this resolution? This would be provided by our team only. So same way, accessing that with using the storage variable on as purchase. The required condition should be that the purchase should be in the disputed category. Okay. Then we'll also check that the person who is trying to resolve this dispute should only be the manager. Okay. Some other person should not be allowed to resolve this. This should be done by someone from our team only. So then we would require that the resolution should be either 0 or 1 only. Just make it less than equal to 1. Otherwise, it will be invalid resolution. Okay. And we can do one thing. We can just for our team, we can say that 0 is for buyer and 1 is for the seller. What does this mean is the value provided by our team would be either 0 or 1, and that means that if they provide 0, that means the funds would be transferred back to the buyer's account. Okay, so the buyer must have not received the promised product. That's why he have raised this dispute, and then in the while resolving the dispute, if our team finds that yes, the buyer is saying correct, so he will get back all the amount. Okay, and if the team finds out that the seller is correct, so what will happen is the amount would be transferred to the seller's account. One for seller. So we have made this comment too for letting our team know. And now let's make complete the logic. Resolution double equals 0. Buyer balances purchase dot buyer. So what will happen is in the case when the resolution came out that the buyer was correct, so the buyer's balances would get in the amount, and we need to subtract that amount which was already transferred to the seller's account. It is true that he would not be able to withdraw it until unless the purchase has been marked complete, but we need to just make sure that we update both the values. Okay, the buyer's balance also and the seller's balance also. So equals to purchase dot amount Okay, and seller balances would be purchase dot seller. Okay, you are accessing that. The seller balances mapping. Okay, using the purchase dot seller as the key, and then after that, purchase dot amount. Okay, so we have subtracted that amount from the seller's balances, and else let's do one more thing. Else if the resolution came out to be 1. Okay, that was in case of 0, and now it's in case of 1. What we would want to do is you would want to do nothing, just say do nothing and leave this empty. Okay, because we do not want to change anything in that case. And else if maybe the team passes something else, or maybe if some error happens, or maybe the team passes some other value other than 0 or 1, maybe, so what will happen, or maybe in case of some other things, we want to revert that invalid resolution. Revert invalid resolution. Although the team would not be able to pass something other than 0 or 1, otherwise it would be marked as invalid resolution. But just to cover any other cases, we have here also kept in the else part that it will revert invalid resolution. And so you must have noticed, I have told you before also, it means that positive integers. Okay, unsigned integers. Okay, only the positive side. So what it means is we have marked it less than 0, less than or equal to 1. So it means that it cannot go negative. That basically means that the value can only be 0 or 1. So that's it, and we'll mark the purchase after the dispute has been resolved. What we'll do is we'll mark the purchase as, okay, so we'll mark the purchase as complete. Purchase dot completed equals true, and then we would be emitting the event dispute dispute. Okay, dispute result. Looks like I have not created this event, and let's check this. Okay, so the events which we have created is, okay, so yes, the dispute resolved. Okay, purchase disputed is correct. Yes. So one event is missing, that is dispute. Dispute resolved. Into 6. Purchase ID. Resolution. Yes. 2. Emit. Then what it will emit? It will emit that the dispute has been resolved. Okay. So emitting this purchase, disputed, and dispute resolved. Okay. Yes, in the resolved dispute part, it will be like the dispute has been resolved. This dispute resolved. Okay. Since ID and then solution. Okay. So this function is also complete. So let's now move on to our some last functions. That would be, we would be allowing the function. We would be creating the functions to allow the buyer to withdraw the funds and the seller to withdraw the funds. Okay, so 256 a movement amount equals to balance to withdraw. After that, we check my balances message dot sender is 0 and we'll transfer the funds able message dot sender for trans. Okay, so we just check the buyer balances here. Okay, they will retrieve the amount and then we'll check whether the amount is greater than 0 or not, and then we'll just transfer it and we'll emit the event that funds withdrawn. Okay, the account will be the message dot sender and the amount will be the amount only. Okay, looks cool and fine. So now let's make the function to allow the sellers to withdraw the funds. Seller funds external please. The required conditions would be the caller should be the seller only. Seller when comes to message dot sender, otherwise it would be unauthorized. It's not being yet deleted. Okay, and so after checking the required conditions, okay, so in 256 amount, let's check for the amount, the balances, the amount associated with this address, sender. Okay, require the amount should be greater than 0. Okay, otherwise show that no balance is there to draw. Looks cool. Okay, so and update the seller balances message dot sender balances with this address to be 0 and transfer table 6 dot transfer. amount. Okay, then we limit this event called as funds withdrawn. Message to sender amount. Looks like our smart contract is now complete, and now let us just test it out, and I will demonstrate it to you how this works. So let's just first of all compile it. Okay, so let's try to deploy it. Okay, okay. So these are all the functions available to us. You can see that the manager is the address which deployed this smart contract. Okay, so now let's try using the add product function. Okay, so say this address is the seller and this wants to sell something, say tomato. Okay, and till now you are working with ethers. Now let us work with the smallest unit available in this in ethereum. Okay, that's way. Okay, so what is way? We all know that you must be knowing if you have watched my previous videos, but 1 ether equals to 1 into 10 to the power 18 ways. Okay, so you can know that how small unit way is. Okay, so let's just randomly use it. Okay, so let's say how many zeros are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So that basically means that we have kept the price of this tomato as 0.2 ETH. Okay, because if there were 18 zeros, that means that 2 ETH itself, but there are 70 zeros, so that means that we have kept this price as 0.2 ETH. So let's keep it. Okay, so anyone can know from this okay, by calling this products mapping. Okay, so anyone can know about the product. Okay, this is a tomato, and our first product is a tomato, and this is the price which someone would need to pay to buy it. And is it available? Yes, and the seller is this address CB2. So now say someone wants to buy this address now wants to buy this. Okay, so let's just so the value which he will need to pass is the exact value. Okay, and say if the guy mistakenly sent some other amount. Okay, add some zeros or something, and let us see what happens. So in the buy product, while calling this function, he would need to provide the product ID, and that product ID is one here. Okay, so okay, so that's a lot of ethers basically. So let's reduce some, and let's check what happens. So it will show incorrect amount sent, and the correct amount is this amount only, and we need to send this much amount. The buyer needs to send that much exact amount. Okay, so you can see now when he will try to send. Okay, see, this gets successfully executed, and the smart contract got the balance of 0.2 ETH. So now let's check the balance of the seller. Okay, this guy was the seller of this tomato, and as you can see, this is the seller. And now let us check the balance of the seller. How much balance this does this seller is having? So this guy is having this much balance. But now what will happen is this guy cannot actually withdraw the funds. Okay, until and unless the purchase has been marked as complete. And for that, what we need to do is we need something called as the purchase ID. Okay, that was a product ID which was specified while buying, and now we need a purchase ID. Okay, as I told you earlier also, for uniquely identifying each purchase. So how we would be able to know that is we need to just put the address of the buyer along with the product ID. So for purchase IDs, what will happen is that as you can see this purchase IDs, this is an array of UN 256. So what will happen is as this guy, this account made his first purchase. So the index of the at which the array, the purchase ID would have been in this array, in the array of UN 256, the index at which the purchase ID would be stored is the zeroth index, because this is the first time this guy, this address has made a purchase. So at zeroth index, we would be able to know the exact purchase ID. So this is the purchase ID. See this. So let's try if the seller tries to just mark the purchase as complete. Say what happens is the seller sees ki, okay, the now I have got this much amount of ether into the smart contract. So now let's decide not to send the product, and let us try to mark the purchase as complete. So the purchase ID is here, and let's try. What will happen is unauthorized. The seller is not authorized. Nah, not even the seller, even the manager would not be authorized to do so. Okay, so complete purchase. What will happen is unauthorized. So say what will happen is the seller knows ki, okay, I cannot just get this funds, withdraw these funds, so I need to send the product. So what will happen is he will send the product, and after sending the product, when the buyer will receive it, he will then mark this purchase as complete. And you may say that maybe this buyer may never mark this as complete. So there is no incentive for the buyer to do so, because from his account already the zero point 0.2 ETH has been deducted and they are stored in this smart contract. Okay, for making this smart contract even better, what we can do is we can introduce some time duration, or for a specific time period, that after that time period, if the buyer does not mark the purchase as complete, what will happen is the purchase will itself get marked as complete, so that maybe because of some human error, or maybe the buyer may never may forgot to just mark this purchase as complete, so it may not happen. So for that we can introduce things such as after a certain period of time the purchase will automatically critically gets will get as complete if the buyer has not yet raised any dispute, or have received the product successfully but have not marked this purchase as complete. So we can do that, but for now this works completely fine, and because there is no incentive for the buyer to not mark the purchase complete after receiving it, there can be a case if he gets something else, maybe the product which he ordered was broken or something, so he can raise a dispute. That can be the case, but there is no incentive for the buyer to not mark the purchase as complete if the product has been reached successfully to him, and the product is the one which he desired. So say the buyer get the buyer got the product which he wanted. So in that case, he will try to just he will mark the purchase as complete. So now the purchase has been completed, and now when the seller will try to just withdraw the balance, he would be able to withdraw the balance. Okay, to withdraw the funds, you just need to provide the purchase ID, and then you can see currently there is the balance of zero point 0.2 ETH into the smart contract. But as soon as the seller clicks on the withdraw seller funds, what will happen is these funds will get transferred to the seller's account. Simple as that. And say in case of a dispute, that dispute case is simple. What will happen is, say now someone else, say this person is the seller and wants to sell potato, and for this value, say, okay, let's make it one. What will happen is, and now this guy is the buyer and he tries to buy it. Tries to buy, and you can check at second position, it would be potato. Okay, so this is the balance, and now what will happen is, let's check. Okay, so he wants to buy it, and this guy wants to buy it, and he has provided the value. Let's click on buy product at second. So what will happen is, okay, see, the buyer successfully transferred some funds into this smart contract, and the seller will now send the potato, and maybe the potatoes were sour, or maybe the potatoes were of bad quality. So now what will happen is, the user can raise a dispute that, okay, I received the potatoes which I received were not as good as they were claimed, and now I want to raise a dispute. So for raising a dispute, what will happen is, we need, again, we need the purchase ID, and that purchase ID is just, for that we need to just provide the buyer's address along with the purchase. Okay, so this is his first purchase, so that is going to be zero only. And see, this is the purchase ID, and for that, now he wants to raise a dispute. Let's say what will happen. Let's see. So, okay. So the dispute has been raised. So currently, if you will check for the seller, this seller, okay, this seller would have been having these funds into his account, but he cannot withdraw them until and unless the is marked as complete. So now what will happen is, after the the buyer has raised a dispute, what will happen is, someone from our team, in the, just imagine, in the case of a real world scenario, someone from our team will now check, okay, who is correct, and may ask some photographs and all, the proofs that the potatoes were not as good as they were claimed, and say, let us say the manager, okay, this is the guy who would be responsible for resolving the disputes. Okay, so this guy now decides ki, okay, actually the buyer is correct, and I want that the buyer should get the refund. That, yes, the correct thing would be that the buyer should get the refund. What will happen is, he will just provide the purchase ID along with his resolution. And as I have told you, the resolution was 0 for buyer and 1 for seller. And let us say he decides that buyer is correct. And for your convenience, just for showing you, I will just show it to you that the buyer balance, okay, currently the buyer balance is 0, and the seller balance, I have shown it to you, is this much amount. And what will happen is, when the manager decides that, yes, this buyer is correct, and just decides to resolve the issue by saying that, okay, the decision is that the buyer should receive back his funds. So now he just clicks on resolving the issue. What's the error? Purchase is not under dispute. Okay, maybe I have provided the wrong dispute ID. So this is the dispute ID, and this is, yes, so this purchase ID, okay, and that now he decides that the buyer is correct. Okay, see, it gets successfully executed, and what will happen now is, now the seller's from the seller's account. Okay, so this was the seller only. You can check. Okay, 7F2. You can check at the last 7F2. Okay, this is the seller. This is the seller who wanted to sell the potatoes. Okay, CAB. This you can check. Yeah, so this is the seller. You can check, and now his balance would be zero. And for the buyer, you can check the buyer is this guy, and this guy was earlier having zero, okay, in his balance, and now he must have got this account, these funds which he transferred earlier as back. So now he can just withdraw funds, okay, withdraw buyer funds. See, it becomes zero, zero, and the buyer now gets back his funds. So that's all for today, guys. I hope that you must have understood something. It may seem overwhelming at first, all these things, but I would just suggest you to go through it to test it out. And if you wish, you can also improve it. And thank you guys for watching. See you soon. See you on the 12th day. Bye bye.